All right, continuing on with section 13.1, relative extrema, we're doing number 37. Y equals x squared minus 3 over x plus 2. So we're going to need to use the quotient rule here to differentiate this. So we've got y prime equals the derivative of the first function, which is 2x, times the second function, x plus 2, minus the first function, x squared minus 3, times the derivative of the second function, which is just 1, over x plus 2 squared. All right, so let's expand out the terms in the top. We have 2x squared plus 4x minus x squared minus 3 over x plus 2 squared. So we have x squared plus 4x minus 3 over x plus 2 squared. So then y prime equals x minus 3 and negative 3 times negative 1. That should give us negative 4. Did I screw up here? Oh, here we go. This is where I screwed up. So this is minus negative 3. So that's a 3. And that's why I was getting it wrong. It's x plus 3, x plus 1 in the numerator over x plus 2 squared on the denominator. All right, so we're gonna, the critical values are then x equals negative 3 and negative 1. But we also need to look at the value for the discontinuity, which is negative 2, just to identify the behavior of the graph around that interval as well. So x equals negative 2 is a discontinuity. So let's set up some intervals here. We've got negative 1 to infinity. And we've got negative 1, negative 2, negative 1. And then we have the interval between negative 3 and negative 2. And then we have, sorry about the tight space here, hopefully it's not too confusing. And then we have negative infinity, negative 3 is the final interval. Okay, so let's look at the components of the derivative. We have x plus 1, x plus 3, and x plus 2 squared. All right, so let's look at the first interval from negative infinity to negative 3. So let's plug in negative 4. Negative 4 plus 1 is going to equal negative 3, so that's going to be negative. Negative 4 plus 3 is going to be negative as well. And negative 4 plus 2 squared is going to be positive. And so negative times a negative times a positive is going to give us a positive f prime of x. And so the function is increasing to the left of negative 3. Then we have the interval between negative 3 and negative 2, so let's put in negative 2.5. Negative 2.5 plus 1 is negative. negative 2.5 plus 3 is positive. Obviously, the denominator is always going to be positive. So we have a negative times a positive, which gives us a negative. So the function is decreasing between negative 3 and negative 2. And because the function is increasing before negative 3 and decreasing after, negative 3 is a relative max. Alright, now let's look at the interval between negative 2 and negative 1. Remember, negative 2 is not a critical value, it's a point of discontinuity. So negative 2 plugging in, let's plug in negative 1.5. Plus 1 is going to give us a negative. Negative 1.5 plus 3 is going to give us a positive. So again, it's decreasing on that interval. And then finally, negative 1 to infinity. Let's plug in 0. 0 plus 1 is positive. 0 plus 3 is positive, so it's positive, so it's increasing to the right of 1, of negative 1. Decreasing to the left of it, so we have a relative minimum. So negative 1 is a relative minimum. Alright, that's a lot to do on a small piece of paper. I'm sorry if it looks a little messy, but hopefully you followed it along in the video. We are done with number 37.